But then this is where we get interesting here. So this is where we have more than one solution, or no solution, or one solution here. So there are three things happening here. So this concept is for triangles given two sides and an opposite angle, and one opposite angle. So suppose we are given A, B, and A. So this whole concept is based on the premise that we know A, B, the lowercase b side, and then the angle A. But then we can use this idea for, say, if we're given lowercase b, b, and angle A, or angle B, or if we have AAC or something like that. So it doesn't have to be generically like this, ABA. We can change this around, and that's what we'll be doing in our code too. We will need to reason and apply this idea to what we need to solve. But anyway, when we have no solutions, that happens when A is less than B. But when we have two solutions here, such as here, this is no solution here. But then no solution happens when also A is less than B sine A. So if A is less than or equal to B, that's going to be no solution. But not right away, because A is less than B here. It's not equal to, but if it's greater than B sine A, then we have two solutions. And then if A is equal to B sine A, or A is less or A is greater than or equal to B, then we have one solution, such as here. All right, so let's do some problems now. So I'm gonna erase these here, and now we're gonna solve an example. We're gonna determine, we have a triangle, we're given three pieces of information. We're gonna determine if it has no solutions, one solution, or two solutions, and then we're gonna solve the given triangle. All right, so for a problem like this, all right, so what I've done here is that I've made a little chart or little box like this. This box here I made. So this is copying basically the information from this bigger box, that the key concept that was above. So I've made for each of the conditions, if it's one or no or two solutions, and these are all in the three examples that we will be looking at next. So let's look at this example in a triangle ABC. So we have B, angle B is 95, B is 19, and C is 12. So for no solution, we have A is less than B. In this case, we are comparing B and C though. All right, so what I've done here is basically copying the information from the bigger text box. That would be this text box here, everything here, into our example below. So our example is giving angles and two sides, and what I've done is we have no solution. That's the condition that happens under it, one or two solutions. All right, so let's check and see what condition we're under, and then go from there. So in ABC, B is 95, B is 19, and C is 12. So let's see if it's one, no, or two solutions. So is B less than or equal to C, or B is less than C sine B? So we have B equals 19. That's not right there. So if B is 19, then B is greater than C. So this doesn't apply here for us. We can just stop there. We can, if we check one of the conditions and it doesn't work, then we can stop there. We don't have to even check B is less than C sine B. So is it one solution? So is B greater than or equal to C, or B equal to C sine B? So this is true. This is definitely true here. B is greater than or equal to C. So do we need to check B equal to C sine B? Based on, I can just go based on the first condition that B is greater than or equal to C. We don't even have to worry about B equal to C sine B, because we know that it is one solution in this case. So this is where we stop here, because for the last condition, two solutions, we have C is greater than B, greater than C sine B. C is not greater than B, so this doesn't work either. So it is one solution in this case. So all we need to do now is solve our triangle, so using law of sines. So we have, let's go back up. We have sine of 95 over 19 equals sine of A over, actually C. Sine of C. That's the information that we know. This is C right here. So C over 12. We can't solve for A yet. All right. So now we can do the cross multiplication and all that good stuff. So we get, in this case, we're solving for C. So we have 19 sine C equals 12 sine of 95. All right, so that means sine of C equals 12 sine 95 all over 19. That means C equals inverse sine, arc sine, of 12 sine of 95 over 19. So that means C equals, getting our calculator, check our calculator, I have another problem similar to this saved in my calculator. So actually, let's just go back here and change the numbers in this, from this problem. Bring the calculator back here. So we have inverse sine of, actually put it over here, sine of 95, and then delete all this, times 12, and we need to insert a parentheses there. This is over 19, and then hit enter. So C is approximately 39 degrees. C is 39 degrees. Okay, so now we can solve for A. We can solve for A, and then we can solve for the sides. If we, well, actually, let's just solve for side. Well, we know side C, so we don't have to. We can now go to side angle A and side A. So angle A, measure of angle A equals 180 minus B, we said, is 95 plus 39. So 95 plus 39 is 138. So this equals 180 minus, not 130, is 134 minus 134. And then this equals 46. Put the degrees there. So A, therefore a measure of angle A is 46 degrees. And now I can solve for the side by using law of sines. So sine of 46 over A equals sine of, let's use the information from B, sine of 95 over 19. Since we approximated the angle and side for C, so sine of, we're not going to use that. We're going to use B over 14. Let me make sure it is 14. It's 12. C is 12. All right. So A equals sine 46 times 12 over sine 95. And then I can go back to my calculator now. So let's change some of these numbers. So we have 12 times sine of 46 divided by sine of 95. We hit enter. So A is 8.67. A is approximately 8.67, rounded to two decimal places, hundredths place. All right, so now we can conclude that angle A equals 46 degrees, side A equals 8.67, and then we found C, I believe, yeah, angle C equals 39 degrees. So that's how we solve that problem. All right, so let's do the same thing here for example 3 and see what we have here. So now I need to verify which one of these conditions we're in. Is it no solution, one, or two solutions? So we have B is 95, lowercase b is 10, and C is 12. So right off the bat, B is less than C. B is 10 and C is 12. All I need to check is is the two solution case here, down here. So just because B is less than C doesn't mean we can say that we have no solutions. We need to check if B is greater than C, so all we need to check. So get our calculator. Let's do, oops. So, is this bigger? So, let's do 12 times sine of 95. And this is 11.95. This is greater than B. So, this chunk here is greater than B, not less than B. So this doesn't help us either. So it is the no solution in this case. So this triangle does not have a solution. It's not. We cannot solve this. So one thing we can do here is see why this doesn't work. Make a triangle and kind of visualize here why this is not true. So if we had an angle of, say we have an angle of 95 degrees, like this. Call this 95. This looks bigger than 95. Oops. So if we had an angle like this is closer to 95 degrees. This is 95. So this is angle B. And let's make this C here. And let's make a dashed line. So this angle then would have to be, let's call this C. So this side then here is 12. And then we have B is 10. This doesn't make sense, right? So this 10 here, this long side looks greater than the 12 here. So this isn't true. If it was 10, it would have to end, say, about here. This would end about here, and the triangle doesn't end there. It ends at C all the way here. Because otherwise, if it ended here, then this angle would not be 95 degrees. Would be less than 90 degrees. So that's why this doesn't work. This doesn't have any solutions. So no solutions there. The 10 is, in this case, 10 is less than 12, but based on the dimensions of the triangle, this 10 is greater than 12. So the side opposite of the bigger angle would be sort of like the hypotenuse of right triangle.